Hello, welcome to Visionaryx, our podcast where you can have real and simple conversations with us about various tools and technologies. I'm NixOS, and
I'm Docker. In this podcast, we dive into exciting discussions about simple and deep technical topics in the world of DevOps and cloud. You can find the full transcript of this episode on our website, visionaryx.tech, to follow along with us. Stay tuned and enjoy the adventures in the world of technology. What? Nix, what a nice surprise. I did not know you still come to these events.
hello, Docker. I am surprised to see you here too. I thought you only go to new, cool startups now.
Well, everyone needs me everywhere. How about you? Are you still trying to make people think your hard bits are worth it?
I came to see if DevOps is all grown up now. More. We still have a long way to go.
That's nice. Maybe we can talk more later. I'm sure we have lots to say.
Yes, of course. I really want to see how much you got better after all these years. Or maybe you didn't?
Let's talk now, not later. I make same places everywhere by isolating applications. This means repeatability and trust in any place.
That's nice, but I go one step more. I make the whole system from base to top. Even the Linux kernel is under my control. This means full repeatability, not just for applications.
Well, you control the whole system, but doesn't this make things more complex? I do things easy and go straight to the point.
Complex? Maybe at first. But when you can reproduce the whole environment with one config file, life gets so much easier. Think how much time you save when you don't worry about environment differences.
I agree your idea is nice, but I still think my simplicity works better for most teams. Not everyone can or wants to manage the whole operating system.
True, but don't forget I'm not just for managing the whole system. I can be used just for package management too. And when it comes to reproducibility, I have unique functionality.
Like what? I can make reproducible environments with my Docker files too.
True, but can you make sure building a Docker file twice gives exactly the same result? I can guarantee this, even years later.
Well, that's really an interesting capability. But don't you think this level of control is too much for most projects?
Maybe for small projects. But when we talk about big, complex systems, this precision and control can be the difference between success and failure.
True, big systems have special needs. But for managing dependencies, I use image layers. Each command in Dockerfile makes a new layer. This helps with fast caching and updates. For example, we can use multi-stage builds to have only the tools we need to run in the final image.
That's interesting, but my approach is different. I use a hash-based package management system. Each package is stored in /nix/store with a unique hash. This lets me install many versions of a package at the same time without problems. For example, we can have Python 3.7 and 3.9 together with no issues.
That's a good feature, but can't it make the CI/CD pipeline complex? With me, you can make one image and use it in all environments.
True, but think about a case where you need to test a service with two different OpenSSL versions. With me, you can have two fully isolated environments with different OpenSSL versions and be sure there's no conflict.
I agree that's a big advantage. But I still think for most cases, having one image with Docker Compose for orchestration is simpler and more practical.
True, but I have more advanced features. With Nix Flakes, we can specify all dependencies exactly, including system tools like GCC or even a specific Linux kernel version. This means 100% reproducibility, even at the operating system level.
This level of detail is really impressive. But is this extra complexity worth it for the DevOps team?
For complex systems, definitely. Think about a microservice architecture with tens of services, each with its own special dependencies. With me, You can use NixOS containers that work like Linux containers, but with the advantage of precise dependency management.
I must say these features are very powerful. But for starting and for teams new to DevOps, I'm still the easier option.
I totally agree. Every tool has its place. But when projects get big and complex, my abilities in precise dependency management, reproducible builds, and full system rollback can really make a difference. Especially in regulated environments like fintech or healthcare that need exact auditing.
Well, now that we're talking about real examples, let me bring up a DevOps scenario. Imagine you're working on a big microservices project that uses several programming languages. For example, one service with Python, one with Node.js, and one with Go. I can make a separate image for each one that has all their dependencies inside.
This is a good approach, but let me show you how I can manage this scenario better. I can not only make separate environments, but I can specify exactly which version of each dependency each service uses, even system dependencies.
Well, that's interesting. But how does this help us in practice?
Imagine one of the Python services needs a specific OpenSSL version, while the Go service needs a different version. With me, you can have both versions at the same time without any conflict.
That's a good feature, but I can do this too with separate images.
True, but think about when you need to apply a security update to all services. With me, you can do this with a small change in the package definitions and be sure it's applied everywhere.
Well, this can really help in managing big systems. But is this complexity worth it for smaller teams?
For smaller teams, it might seem like too much at first. But think about when the project grows. With me, you have a strong foundation for managing dependencies from the start that grows with you.
Well, that's a good example. But let's think about a more real scenario. Remember what happened when the Log4j vulnerability was found? Everyone was going crazy trying to figure out which of their services were vulnerable.
Yes, exactly. And this is where I really shine. With my system, you could know in just a few minutes exactly which services were using vulnerable Log4j versions.
Well, you can do this with me too. You just need to check all the Docker files.
True, but think about a system with hundreds of services. With me, you can see all dependencies of all services with one simple command. And not just direct dependencies, but dependencies of dependencies too.
This really can save a lot of time.
Exactly. And the best part is, when a new safe version of Log4j came out, you could update it across the whole system by changing one line in the package definitions. And because I guarantee that each build gives exactly the same result, you could make this change with peace of mind.
Well, this really impressed me. But is this level of control needed for all projects?
Maybe not for everyone. But when it comes to security and reliability, having this level of control can be the difference between a disaster and a simple update. And don't forget, this was just one example. This ability is useful for any type of dependency and any kind of update.
True, you have good abilities in managing dependencies, but when it comes to speed and efficiency, I'm the best. Using the Overlay 2 storage driver, I can manage image layers very well. This means pulling and running containers happens in just seconds.
Speed is good, but efficiency isn't just about running fast. I use a hash-based package management system that stores each package with a unique hash in /nix/store. This means only exactly what's needed gets installed, not one byte more. For example, for a Node.js app, I only install the exact versions of npm packages specified in package lock.json.
Well, it's true I sometimes have extra things, but using multi-stage builds and Docker ignore, I can make final images very efficient. Also, my layer caching ability makes later builds much faster.
But your approach can still cause problems. I use a derivation system that defines all inputs and build steps in a declarative way. This means every build is exactly repeatable and predictable. For example, if you're compiling a C library, I know exactly which GCC version was used with what flags.
I agree, that's an advantage. But don't you think this high precision can slow down development? With me, developers can easily enter a container and debug with Docker run, then -it, then the image name, and finally /bin/bash.
True, it might take a bit more time at first, but I have similar features too. With Nix Shell, developers can enter an isolated environment that has exactly the project's dependencies. Also, I use a smart garbage collection system that keeps disk space optimized.
That's a good point. But I still think for smaller projects and startups, the simplicity of my Dockerfile and Docker Compose has more advantages.
Maybe for starting, but even for small projects, I have many benefits. For example, with Nix PKGS, you can easily have different versions of compilers, libraries, and tools side by side without any conflict. This is very useful for testing compatibility with different versions. Let me give a technical example. Imagine you're building a Node.js app. With me, you can specify exactly which version of Node.js and npm you want to use. You can even control global packages precisely. This means when you run npm install, only exactly the packages you need are installed, without any extra dependencies.
Well, that's good. But I can also make optimized images using multi-stage builds in Dockerfile.
True, but I go one step further. Using my dependency tree feature, you can see exactly what dependencies each package has and how they're connected. This means you can identify and optimize shared dependencies, which reduces the final size of the program.
This is an interesting feature, but is this extra complexity worth it?
Definitely. Think about a scenario where you're building a Go microservice. With me, you can produce a fully static binary with no external dependencies. Even libc is statically linked. This means a final executable that's just a few megabytes, compared to a Docker image that's usually at least tens of megabytes.
Well, that's really impressive. But does this work for all languages and frameworks?
Of course not, but I'm very flexible. For example, for a Python app, I can create a virtual environment that only includes the needed packages. I can even optimize binary packages like NumPy to include only the used code.
This is really interesting. But do these optimizations have a big effect on performance?
Definitely. Think about a Kubernetes cluster with hundreds of pods. When each pod is a few megabytes smaller, this means better use of resources, faster booting, and even less network traffic for pulling images.
For rollback ability, I have a simple but powerful system. Using Docker tags and versioning, I can easily switch between different versions. For example, with one command that includes Docker service update, then --image, followed by the app name and version, and finally the service name, I can quickly go back to a specific version. Also, with Docker Swarm or Kubernetes, I can use rolling updates, which allow for fast rollback.
Interesting, but I have a system-wide approach. Using NixOS generations, we can roll back the whole system to any point in the past. This includes everything, from the kernel to system libraries and even network settings. For example, with the command NixOS rebuild switch --rollback, we can go back to the last working generation.
This is a powerful feature, but is this level of control necessary for most use cases? Usually, rolling back the application layer is enough.
True, but think about a more complex scenario. Imagine a new CVE is published for a system library like OpenSSL. With Nix, we can see exactly which services are using the vulnerable version, and if the update causes problems, we can roll back the whole system to its previous state, without worrying about inconsistency between different layers.
I agree this feature can be very useful in some cases. But doesn't this waste storage? Keeping all these versions must take up a lot of space.
That's a good question. We use a content-addressable storage system. Each file is stored with a unique hash and exists only once in the system. This means we don't have duplicate data. Also, With nix-collect-garbage, we can remove unnecessary files while keeping the ability to roll back to key points.
Interesting. We can also free up extra space with Docker system prune, but your approach seems more comprehensive.
Exactly. And don't forget, this isn't just about storage. When we use NixOS, we can even version control configuration management. Imagine being able to manage all system changes like a Git repository.
This level of control can definitely be very valuable for enterprise environments, especially in compliance and audit scenarios.
Absolutely right. And for DevOps engineers, this means they can apply changes with more confidence. If something goes wrong, they can return to the previous state with one simple command, without worrying about data loss or inconsistency. And with NixOS generations, DevOps engineers can manage all system changes like a Git repository.
True, your capabilities are powerful, but we can't ignore that your learning curve is challenging. With a simple Docker file and Docker Compose YAML file, I provide the ability to create and manage multi-container applications. Most DevOps engineers are familiar with these concepts.
I agree, my learning is more complex, but my power is beyond imagination. With Nix expressions, you can define all aspects of a system in a declarative way. For example, you can use nix-pkgs.mk shell to create a fully isolated development environment that includes exactly the tools and dependencies you need without interfering with the main system.
But this complexity can slow down CI/CD pipelines. With me, a DevOps engineer can easily define a multi-stage build in Jenkins file or GitLab CI and benefit from caching.
True, but Nix integrates with Hydra, a dedicated continuous integration server, which provides distributed builds and advanced caching. Also, with Nix Shell, you can create reproducible CI environments that are exactly like the local environment.
I agree these are big advantages. But doesn't this difficult learning make DevOps teams avoid using Nix, especially when deadlines are tight?
This challenge is real, but we're working on tools like nix-pkgs FMT for formatting and automation. Also, Nix Flakes are introducing a standard structure for Nix projects that improve reproducibility. In the end, Nix's benefits in managing complex system configurations are worth this initial learning.
These improvements are interesting, but I still think I'm the easier option to start with.
True, but think about when you need to build a complex system like a Kubernetes cluster from scratch. With NixOS and nix-pkgs.kubernetes, you can define all aspects of the cluster, from container runtime to network policies, in a declarative way. This is not only reproducible, but can also be version controlled and audited.
Thank you for listening to Visionaryx. You can find more technical and practical discussions on our website, Visionaryx.tech.
Thank you for listening to Visionaryx. You can find more technical and practical discussions on our website, Visionaryx.tech. Next time, we'll be talking about cloud. Goodbye for now.
Goodbye.